A company produces steel rods. The lengths of the steel rods are normally distributed with a mean of 254.8 centimeters and a standard deviation of 1.6 centimeters. Find P sub 58, which is the length separating the shortest 58% of rods from the longest 42%. The first thing I notice while reading this problem is that I have a set of data that is normally distributed. And that ultimately guides me in choosing a method of solving the problem in the end. But it's a great idea to organize the information based off of that knowledge. And the best way to do that is to draw a bell-shaped curve and label it with the pertinent information, which is the mean of the distribution, so 254.8, and the standard deviation of 1.6. So the mean is right in the center. And these values here, 254.8, are measured in centimeters. So the axis here is a number of centimeters. All right, now find P sub 58. So what that means is the 58th percentile. That's how you read that. And the 58th percentile, which is what we want to find, that is by definition a value separating the shortest 58% of rods from the longest 42%. So you really don't need all that extra information there. Once you know you're looking for the 58th percentile, you know that the amount of area you're interested in is 58% underneath the normal distribution curve, and percentiles are always organized to be areas to the left. So this amount of shaded area is 58% of the total. Now, you're looking for a length, and that's going to be in centimeters. So this value right here that's missing is a number of centimeters. So it's not a probability. So that tells me that to find it, I'm not using normal CDF, because normal CDF always gives probabilities or percentages. Inverse norm takes probabilities or percentages and gives values that are relative to a kind of unit, like centimeters. So now it takes three inputs. The first is an area to the left of a given value that you're interested in, and then a mean and a standard deviation. So the area to the left of the value that I'm interested in, the area to the left of x, is 0.58. So that's total area under the curve. The mean is 254.8, and the standard deviation is 1.6. So if I get my calculator to find out what the value of x is, then I would do second vars, which brings up the distributions menu, come down to inverse norm, and give it the three inputs here that I've written in. So 0.58, comma, 254.8, and 1.6. That gives me 255.123. And in terms of rounding, we generally round to the same accuracy as the mean and standard deviation. So that would mean I would round to 255.1, and of course that unit would be in centimeters. But follow any rounding rules that you've been provided. Now some of you may have seen a menu come up when you press the inverse norm. So if you hit the mode key, and I'm going to turn those on, those menus. All right, so when you hit second in vars and come down to inverse norm, here's the menu. All this is doing is, instead of requiring you to remember what the inputs to each function are, it gives you some hints. So the first input to inverse norm is an area. In particular, it is still area to the left, so make sure you put 0.58. The mean is 254.8, and the standard deviation is 1.6. When you hit paste, the calculator will take those values, put the commas in, and then feed to you what the answer is. So 255.1, same answer either way. You just got to make sure that you are giving it the correct numbers.